Hi everyone. So today I will presenting my thesis, and so my name is Li Hao Sun, and today I will presenting my master thesis, and the title is Evaluating Reasoning versus Non-Reasoning Model on the insider tree dataset. So first, to go to the table of contents, so we'll cover an introduction, literature review, methodology, result, discussion, and limitation, future work, and in the last, we have a demo and running the script to training a small piece of training code from my project to showing in the live code from the Jupyter Notebook. So the motivation for that is modern security operations center SOC facing a critical challenging for we will need to extracting the actionable intelligence, which is using machine learning, from the flow of the network host system logs. So AI power the SOC it need handle the huge amount different type of the data. And the challenging is the extremely classical imbalanced data in the insider tree, insider thread. So this is make the detection is very difficult with the standard machine learning model. And the new generation of the recent, not year 2025, the recent model, the new generation large language model, post training by the reinforced learning to give the model the ability to thinking the long chain of thought. So those model is fitting better in our SOC system compared to the static non-reasoning models. Right. So the data set we have posed here is third inside the thread data set in a collection of the insider text data set provide both the background and malicious hack in the artificial data. And provide, I think it's created and maintained by the Mellon University. So the research question is, do the reasoning LLM like DeepSeek R1 outperform the traditional non-reasoning model on this with season-based and inside the thread third R.6 dataset with a budget aware training condition. So the primary objective is to conduct a controllable comparison between the reasoning and non-reasoning model on the third R6.2 dataset with the standard full W season-based representation. For the literature review, and there we just list few here, and most of the paper related or review is relative new. Some is even come out in this August, 2 months from the time I written this paper, and some is pretty quite new and relative like a 2025 or late 2026. It's all detailed in my paper. So the methodology, the data set. So the third inside the thread data set is grouped by the release version. Right, they have R1 3.1, 3.2, and then they release another one R4.1, 4.2, and So we using in this laboratory, we're using R6.2, which is the most recent version they release. A good part for this data set, we have the ground truth including in the data set. So how fast to do the verification. So it's inside the data set, the provider. So it is the good part. So what's the fold up season we were mentioning here is, uh, so you can see the table. We have the log, the data, but before the pre-process, before the we talk, this have ID, date, user, PC. There are a lot of the noise in the data set. So we convert data to a standard for W. Standard is when, where, what, and which. And in that, like you can see the table, we have user, host, star, text, label. So in this, we can give the consistent the data and good for the machine to understand. So the model we compare here is, first we compare the two groups, is non-reasoning and the reasoning model. And in the non-reasoning model, we have the baseline. It's like a linear regression baseline, and this still bird is very small and classifier, and this still R bird, and it's also bigger than the distill bird and the long performer. And in the comparison, we have the Llama 3.1 AB parameter with the compare with DeepSeek R1 and 7B. So the hardware we have is basically a home lab, and we have the Intel i9 CPU, we have 64 gig RAM, system RAM, and 1 terabyte, the SSD, and we're using two GPU. First, we're using the RTX 5080 with 16 GB VRAM for our baseline training, the non-thinking model. But then we realized it's not good enough for bigger enough. The 16 GB VRAM not enough for the training the bigger model. So we're changing to the RTX 6000 Pro, which is 96 GB VRAM. So we're using the training in the R7B AB with a Llama adapter. And the system we're using Ubuntu and Coda as the main core we use. So how the training conduct is that basically we're finding the same data. We purchase the data with both WCSN token, and then we're using the same data and training all the model, including reasoning and non-reasoning model. And we try to make all the similar training weight or weight. So we try to standardize. And the non-reasoning model, we have the distill bird, and a reasoning model. We're training. We have the DeepSeek R7B and although the Llama AB 3.1 AB, and with all the big model, we're using the lower RAM adapter and technique, and both we try to put a apple to apple compare with the DeepSeek and Llama. So we pretty much share the same training weight, and then all the big model we can now using the quant A, the time or the machine. So we use a quant 4. So that's the training status. Right, so this is a workflow. You need to download the RAR search R6 logs. And we're using we split into by the month. I believe it's 12 months each release, so we split by the month. So after the split by the month, we have monthly based file database we separate to the months. And then we're using this, we use this full W season, convert to the full W season. And after the season, the full W season converts then, so we're adding the ground truth to label to the data set and with the ground truth. And after the ground truth, we have the training, the full training data and one training data. Then we using the same model on the different model on the same data to training them. We see the outcome and we put outcome into a table to compare all the different outcome. So the result coming out, and the one thing we need to mention here is the big model and the DeepSeek R17B and the Llama. If we evaluate with the full set, and it taking like 700 hours. So in order we can complete the training without waiting 700 hour plus for the full training, the full verification, and we using the 200K evaluation slide. So it's not full evaluated slide. So that's the result coming out for the big model. Then for the smaller model, we can go through because they're small. We have the machine able to handle. So we verify with the full 1.5 million the data size to verify the smaller model. And the result come out is it's kind of a surprise, right? So first, the result is we can see the DeepSeek R17B it behave better than all other model, but in this comparison table, we can first we separate the color is the dark blue is the full training data set, full evaluate data set. The blue the green is the 200 slides evaluation. So the result is surprise for us. Although the DeepSeek R1 is better, but it's not that much better. Compare DeepSeek R17B is way bigger model than the smaller model we're using as a baseline. We call it encoder baseline. But those models, although they are performed not as good as DeepSeek R1, but the advantage, the margin of the advantage, so small, we almost can ignore. That's the first result we come out. And second result, we're training DeepSeek R1 because we were mentioned before, the data set is extremely unbalanced, right? So we also try to training the DeepSeek R1 and with the balanced data set, which is the positive and negative evenly. It's only a few hundred of them. So we can see that even with training with the balanced data set, because the amount of data is so slow, so compared with training the same model with the much more data, and the results are better. So once I can prove, this show us although the data set is extremely unbalanced, but to fine tune the data, the model does need quite a lot the data to do that. If you have a balance, but you have balanced data set, but you have very little row of the data, so it's not perform good as you have training the same model with a big amount unbalanced data. That's the second part. The third part is we can see that DeepSeek R17B and compare the Llama AB, right? Llama model is similar weight. Llama is not reasoning model with the DeepSeek 7B, right? Llama have 1 billion parameter bigger, larger than the DeepSeek, but DeepSeek R17B still perform better. So the keep up hypothesis open, which means the reasoning model it does better job. But as the first conclusion, although they're better in my lab, in my experiment, and the snapshot we have in our training, although they're better, but still better a small margin than all the baseline in this experiment. So discussion is we are, as I say, that this is just for the training we have done on our local because training will be different. If you have different machine, different parameters, different weight, the result may be different. If we're using the Quant A, Quant 16, or we don't using a lower RAM adapter, so may the result coming differently. And also we are training in the 200 case like on the big model, small model we're using the full training, full evaluation. So the limitation is the first our hard drive is not fast enough. We don't have sufficient the equipment we have not like the college lab. We just the equipment is not that fast. So furthermore is, as I say, we evolve the big model only using 200 slides, 200K slide because we couldn't complete the full site eval because it takes 700 hours plus. And then other variation is because we token is 512 token line, and it is not too long. If you get to extend a longer token window, maybe better. But because we have the algorithm, our system, we cannot put too larger than the 512 token window. So the future work, we want to do the more evaluation, and we also want to do the integrate a matter tag into our data set with the matter data set, and we want to testing the different data set, external data set for the inside the track. And if they have time, we want to do the multi-model my training on the same model and see are these better. In this demo page, what we are going to do is the demo page. We are to do the demo to take around 500 rows from the main data set and perform a quick training for the using the model DStilBer. The reason we choose this model is small, so we can see the training time will be very small. So on the picture, you can see what exactly there's a demo that we will cover, and the file you can see is the GitHub file, which is open to public, and this is the Jupyter Notebook file. If you download the file repo, you should see the file. You're able to run the file and execute the demo work. So, so basically, this is how I showing the demo was the demo code. Jupyter Notebook was run on my local machine. So we import and set up the data set, and we take 500 row out of the main data set, and then we training, and we training take the 500 row data. We we sanitize first, track out how the demo data will be safe, and then we using the 500 rows to training the DStilBer. You can see this is how this is run on my local host. It is verifying. So the training start now. And when the training complete, we evaluate the training, the module after training. So there's a blog code is doing that. So after the eval, we get our result. Of course, this result will be different than the we eval and training with the full site data, but it just demonstrate what the result, how the result come out, how we training the model, and how we collect the data, the result, outcome, and put it into our table to compare.